Subtraction is a mathematical operation that represents the operation of removing objects from a collection. It is signified by the minus sign. For example, in the picture on the right, there are 5 minus 2 apples, meaning 5 apples with 2 taken away, which is a total of 3 apples. Therefore, 5 minus 2 equals 3. Besides counting fruits, subtraction can also represent combining other physical and abstract quantities using different kinds of objects, including negative numbers, fractions, irrational numbers, vectors, decimals, functions, and matrices. Subtraction follows several important patterns. It is anti-commutative, meaning that changing the order changes the sign of the answer. It is not associative, meaning that when one subtracts more than two numbers, the order in which subtraction is performed matters. Subtraction of 0 does not change a number. Subtraction also obeys predictable rules concerning related operations such as addition and multiplication. All of these rules can be proven, starting with the subtraction of integers and generalizing up through the real numbers and beyond. General binary operations that continue these patterns are studied in abstract algebra. Performing subtraction is one of the simplest numerical tasks. Subtraction of very small numbers is accessible to young children. In primary education, students are taught to subtract numbers in the decimal system, starting with single digits and progressively tackling more difficult problems. Notation and terminology. Subtraction is written using the minus sign, minus between the terms, that is, in infix notation. The result is expressed with an equal sign. For example, there are also situations where subtraction is understood, even though no symbol appears. A column of two numbers, with the lower number in red, usually indicates that the lower number in the column is to be subtracted, with the difference written below, under a line. This is most common in accounting. Formally, the number being subtracted is known as the subtrahend, while the number it is subtracted from is a minuend. The result is the difference. All of this terminology derives from Latin. Subtraction is an English word derived from the Latin verb subtrahere, which is in turn a compound of sub, from under, and trahere, to pull. Thus to subtract is to draw from below, take away. Using the gerundive suffix nd results in subtrahend, thing to be subtracted. Likewise from minere, to reduce or diminish, one gets minuend, thing to be diminished. Of integers and real numbers. Integers: imagine a line segment of length b with the left end labeled A and the right end labeled C. Starting from A, it takes b steps to the right to reach C. This movement to the right is modeled mathematically by addition. A plus b equals C. From C, it takes b steps to the left to get back to A. This movement to the left is modeled by subtraction. C minus b equals A. Now, a line segment labeled with the numbers chapter 1, 2, and 3. From position 3, it takes no steps to the left to stay at 3, so 3 minus 0 equals 3. It takes 2 steps to the left to get to position 1, so 3 minus 2 equals 1. This picture is inadequate to describe what would happen after going 3 steps to the left of position 3. To represent such an operation, the line must be extended. To subtract arbitrary natural numbers, one begins with a line containing every natural number. From 3, it takes 3 steps to the left to get to 0, so 3 minus 3 equals 0. But 3 minus 4 is still invalid since it again leaves the line. The natural numbers are not a useful context for subtraction. The solution is to consider the integer number line. From 3, it takes 4 steps to the left to get to minus 1. 3 minus 4 equals minus 1. Natural numbers. Subtraction of natural numbers is not closed. The difference is not a natural number unless the minuend is greater than or equal to the subtrahend. For example, 26 cannot be subtracted from 11 to give a natural number. Such a case uses one of two approaches. Say that 26 cannot be subtracted from 11. Subtraction becomes a partial function. Give the answer as an integer representing a negative number, so the result of subtracting 26 from 11 is real numbers. Subtraction of real numbers is defined as addition of signed numbers. Specifically, a number is subtracted by adding its additive inverse. Then we have 3 minus pi equals 3 plus. This helps to keep the ring of real numbers simple, by avoiding the introduction of new operators such as subtraction. Ordinarily a ring only has two operations defined on it. In the case of the integers, these are addition and multiplication. A ring already has the concept of additive inverses, but it does not have any notion of a separate subtraction operation. So the use of signed addition as subtraction allows us to apply the ring axioms to subtraction without needing to prove anything. Properties. Anti-commutativity. Subtraction is anti-commutative, meaning that if one reverses the terms in a difference left to right, the result is the negative of the original result. Symbolically, if a and b are any two numbers, then a minus b equals minus. Non-associativity. Subtraction is non-associative, which comes up when one tries to define repeated subtraction. Should the expression a minus b minus c be defined to mean minus c or a minus? These two possibilities give different answers. To resolve this issue, one must establish an order of operations, with different orders giving different results. Predecessor. In the context of integers, subtraction of 1 also plays a special role. For any integer a, the integer is the largest integer less than a, also known as the predecessor of a. Units of measurement. When subtracting two numbers with units of measurement such as kilograms or pounds, they must have the same unit. In most cases the difference will have the same unit as the original numbers. Percentages. Changes in percentages can be reported in at least two forms: percentage change and percentage point change. Percentage change represents the relative change between the two quantities as a percentage, while percentage point change is simply the number obtained by subtracting the two percentages. As an example, suppose that 30% of widgets made in a factory are defective. 6 months later, 20% of widgets are defective. The percentage change is minus 33.33%, while the percentage point change is minus 10 percentage points. In computing, the method of complements is a technique used to subtract one number from another using only addition of positive numbers. This method was commonly used in mechanical calculators and is still used in modern computers. To subtract a binary number y from another number x, the ones complement of y is added to x and 1 is added to the sum. The leading digit, 1, of the result is then discarded. The method of complements is especially useful in binary since the 1's complement is very easily obtained by inverting each bit, and adding 1 to get the 2's complement can be done by simulating a carry into the least significant bit. For example, 011000000101110 becomes the sum 0110010 plus 11,101,001 plus 101,001,110, dropping the initial 1, gives the answer 010011110. The teaching of subtraction in schools. Methods used to teach subtraction to elementary school vary from country to country, and within a country, different methods are in fashion at different times. In what is, in the U.S., called traditional mathematics, a specific process is taught to students at the end of the first year or during the second year for use with multi-digit whole numbers, and is extended in either the 4th or 5th grade to include decimal representations of fractional numbers. In America, almost all American schools currently teach a method of subtraction using borrowing or regrouping in a system of markings called crutches. Although a method of borrowing had been known and published in textbooks previously, the use of crutches in American schools spread after William A. Brownell published a study claiming that crutches were beneficial to students using this method. This system caught on rapidly, displacing the other methods of subtraction in use in America at that time. In Europe, some European schools employ a method of subtraction called the Austrian method, also known as the additions method. There is no borrowing in this method. There are also crutches, which vary by country. Comparing the two main methods, both these methods break up the subtraction as a process of one-digit subtractions by place value. Starting with the least significant digit, a subtraction of subtrahend SJ -1, from minuend -1, M1, where each C and Mi is a digit, proceeds by writing down M1 minus S1, M2 minus S2, and so forth, as long as C does not exceed Mi. Otherwise, Mi is increased by 10 and some other digit is modified to correct for this increase. The American method corrects by attempting to decrease the minuend digit Mi plus 1 by 1. The European method corrects by increasing the subtrahend digit C plus 1 by 1. Example: 704 minus 512. The minuend is 704, the subtrahend is 512. The minuend digits are M3 equals 7, M2 equals 0 and M1 equals 4. The subtrahend digits are S3 equals 5, S2 equals 1 and S1 equals 2. Beginning at the ones place, 4 is not less than 2, so the difference 2 is written down in the results 1 place. In the tens place, 0 is less than 1, so the 0 is increased by 10, and the difference with 1, which is 9, is written down in the tens place. The American method corrects for the increase of 10 by reducing the digit in the minuend's hundreds place by 1. That is, the 7 is struck through and replaced by a 6. The subtraction then proceeds in the hundreds place, where 6 is not less than 5, so the difference is written down in the results hundreds place. We are now done. The result is 192. The Austrian method does not reduce the 7 to 6. Rather, it increases the subtrahend hundreds digit by 1. A small mark is made near or below this digit. Then the subtraction proceeds by asking what number, when increased by 1, and 5 is added to it, makes 7. The answer is 1, and is written down in the results hundreds place. There is an additional subtlety in that the student always employs a mental subtraction table in the American method. The Austrian method often encourages the student to mentally use the addition table in reverse. In the example above, rather than adding 1 to 5, getting 6, and subtracting that from 7, the student is asked to consider what number, when increased by 1, and 5 is added to it, makes 7. Subtraction by hand. Austrian method example: 1 plus equals 3. The difference is written under the line. 9 plus equals 5. The required sum is too small, so we add 10 to it and put a 1 under the next higher place in the subtrahend. 9 plus equals 15. Now we can find the difference like before. Plus equals 7. The difference is written under the line. The total difference. Subtraction from left to right example: 7 minus 4 equals 3. This result is only penciled in. 15 minus 9 equals 6. Because the next digit in the minuend is not smaller than the subtrahend, we keep this number. 3 minus 1 equals 2. American method. In this method, each digit of the subtrahend is subtracted from the digit above it, starting from right to left. If the top number is too small to subtract the bottom number from it, we add 10 to it. This 10 is borrowed from the top digit to the left, which we subtract 1 from. Then we move on to subtracting the next digit and borrowing as needed, until every digit has been subtracted. Example: 3 minus 1 equals. We write the difference under the line. 5 minus 9 equals. The minuend is too small, so we add 10 to it. The 10 is borrowed from the digit on the left, which goes down by 1. 15 minus 9 equals. Now the subtraction works, and we write the difference under the line. 6 minus 4 equals. We write the difference under the line. The total difference. Trade first, a variant of the American method where all borrowing is done before all subtraction. Example: 1 minus 3 equals not possible. We add a 10 to the 1. Because the 10 is borrowed from the nearby 5, the 5 is lowered by 1. 4 minus 9 equals not possible. So we proceed as in step 1, working from right to left. 11 minus 3 equals 8. 14 minus 9 equals 5. 6 minus 4 equals 2. In their place, one places plus or minus signs depending on whether the minuend is greater or smaller than the subtrahend. The sum of the partial differences is the total difference. Example: the smaller number is subtracted from the greater. 700 minus 400 equals 300 because the minuend is greater than the subtrahend. This difference has a plus sign. The smaller number is subtracted from the greater. 90 minus 50 equals 40 because the minuend is smaller than the subtrahend. This difference has a minus sign. The smaller number is subtracted from the greater. 3 minus 1 equals 2 because the minuend is greater than the subtrahend. This difference has a plus sign. Plus 300 minus 40 plus 2 equals 262. Non-vertical methods counting up instead of finding the difference digit by digit. One can count up the numbers between the subtrahend and the minuend. Example: 1234 minus 567 equals can be found by the following steps. 567 plus 3 equals 570. 570 plus 30 equals 600. 600 plus 400 equals 1000. 1000 plus 234 equals 1234. Add up the value from each step to get the total difference. 3 plus 30 plus 400 plus 234 equals 667. Breaking up the subtraction. Another method that is useful for mental arithmetic is to split up the subtraction into small steps. Example: 1234 minus 567 equals can be solved in the following way. 1234 minus 500 equals 734. 734 minus 60 equals 674. 674 minus 7 equals 667. Same change. The same change method uses the fact that adding or subtracting the same number from the minuend and subtrahend does not change the answer. 1 adds the amount needed to get zeros in the subtrahend. Example: 1234 minus 567 equals can be solved as follows. 1234 minus 567 equals 1237 minus 570 equals 1267 minus 600 equals 667. Bibliography: Brown, L. A. Learning as Reorganization. An Experimental Study in Third Grade Arithmetic, Duke University Press. Subtraction in the United States. An Historical Perspective. Susan Ross, Mary Pratt Cotter, The Mathematics Educator, Volume 8, No. 1 and Volume 10, No. 1 PDF.